Alright, so this is the first set of notes for this class. I'm going to try to do video notes for y'all since we're not going to be together for very much. I think it's going to be easier, and we'll talk about this once we meet, for you guys to basically do the notes on your own time. So when we're together on Zoom, it's asking for help and one-on-one tutoring and group tutoring, stuff like that. So this first couple sections is review, but it's been a while, I know, since you guys have done some of this stuff. So hopefully once we start going over it, most of you will be like, oh yeah, okay, I remember doing this. And if there's some things that are a little bit difficult, then we'll get to practice. So exponents and radicals. So a to the n is how you say that. And that's a means a times a times a dot 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 times a n times. A, that big number, is always called the base, n is the exponent. So 7 to the third power means 7 times 7 times 7 3 times, which the third power means, which is 343. And I don't know who here knows this. I don't think many of you are Xbox players, but 343 Studios does Halo, and they just delayed the next Halo game until next year. Just a note, -2 in parentheses like that, that means you take that -2 and you multiply it 6 times. And so a negative times a negative is a positive. So those first two become a positive, those next two become a positive, and those other two become a positive, turning the whole thing into a positive answer. If there's no parentheses, what that means is you're taking that number to the power 6 times, and then you're turning it negative afterwards. So there's a big difference between the parentheses and no parentheses. So be careful of that. These are the exponent rules. A to the m times a to the n equals a to the m plus n. So when there's that multiply sign, or if they're both just in individual parentheses, apparently those are parentheses, they're kind of like crab hands. But, sorry, I got crab people stuck in my head. That's a stupid song. You add the exponents. So x to the fourth times x to the third equals x to the seventh. Because x to the fourth is x times x times x times x 4 times. And then x to the third is x times x times x 3 times. And when you put those together, there are now 7 x's, which is x to the 7th power. Now when there's just a big parentheses, this is what's called a power to a power. You multiply those exponents. So when that outside exponent is just on the parenthesis, that means you multiply them. So x to the fourth to the third power is x to the 12th, because 4 times 3 is 12. This is because an exponent means you multiply it that many times. So there's 4 x's in there, and then you're tripling that, and then 4 times 3 ends up being 12. When you are dividing, so when it looks like a fraction, very rarely will you see like a divide symbol when you do it this way. You're subtracting them. X to the fourth over x to the third equals x, because 4 minus 3 equals 1. And hopefully you remember that when it's something to the first power, you don't have to put that 1 there. You can, most people don't, because you have 4 x's on top, 3 on the bottom. And then when things are the same, when there's multiplication involved, they cross off. So 3 pairs crossed off, leaving you just 1 x on the top. Now, this is something that's harder to remember. When something's a negative exponent, what it's really doing is turning it into an inverse, which means usually you're flipping it. So negative exponents flip. So, and then it turned positive, you can see there. So x to the negative fourth, you turn it into a fraction and it becomes 1 over x to the positive 4. So just got to remember, a negative exponent does not just turn something negative. It's flipping it. In a question like this, a squared b the negative 3 over c the negative 5. Since it's already a fraction, you're not having to put that 1 there. So when I say flip it, that b flips to the bottom and that c flipped to the top. Since that a squared was positive, thus the exponent was positive, it just stays there. Nothing happens to it at all. And some quick reminders, anything to the 0 power is 1, except for 0. 0 to the 0 power is 0. And anything to the first power, and that 1 looks kind of like a 2, but that is a 1, is itself. So 7 to the first power is 7. 9 to the first power is 9. Stacy to the first power is Stacy. This is another hard part to, oh, my pens are moving. Another thing that's hard to remember, but fraction exponents mean basically square roots or cube roots. They're radicals or roots. It turns into the square root of a to the first power, and then square roots are so commonly used, you don't usually write a 2 there. It's just a square root. A to the 7/3 power turns into the cube root of a to the 7th. So what you can see, there's that whatever the top number of that exponent is, it stays with the a on the inside, and whatever is on the bottom goes on the outside. That is blurry. But it says the 7th root of 19 to the 5th power. So we're just going to do that opposite now. So if you look back here, whatever the top number of the fraction was went on the inside, so we're just going to do that opposite. So whatever's on the inside, which was a 5th, oh hey, that's a little bit better, goes on top, that 5 goes on top, and that 7 goes on the bottom. Now, sometimes you can use this to make things nicer. So 16 to the 3/2 power. Whenever these are happening, you can break it up in 2 ways. So 16 to the 1/2 to the 3rd power, or 16 to the 3rd power to the 1/2 power. And we should know a 1/2 really means a square root. The reason this is nice is we should all know what the square root of 16 is. It's 4. And so that turns into a 4, and then you cube it. And 4 times 4 times 4 is 64. So basically all we did is found the square root of 16 and then cubed it. The other way would have been 16 to the 3rd power, which is apparently 4096, because I used the calculator to do it. And then you take the square root of that, you get 64, but nobody knows that. Another thing you'll have to do is simplify fractional exponents with negatives. So since that's on the bottom, we want it to be on top and turn it. So first we'll turn it into a fraction exponent, and then we'll put on top by making it negative. So reducing radicals. This is something that hopefully you did last year, probably when you're doing quadratic formula, if not, maybe in Algebra 1. And we did this a little bit in geometry, but that was years ago. So you need a perfect square factor. I used to always write these down or make people write them down. So that's 4, because 2 squared is 4, 3 squared is 9, 4 squared, and 8 years ago? Man, Crawl would kill me for not knowing this. 4 score and 12 years ago? Anyway, if you guys know what it is, tell me, and well, now I'll be able to tell if you're actually listening to this or not. 4 squared is 16, 5 squared is 25, yada yada. So, which one of those goes into 8? The answer to that is 4. And that's 4 times 2. And the reason we want a perfect square factor is because we know what the square root of 4 is. The square root of 4 is 2. So that just turns into 2 root 2, and that's simplified. It's reduced. So basically we're trying to make that number inside the radical as small as possible. This works because when you're multiplying radicals, like square root of 3 times square root of 5, you just multiply those and turn it into one radical. So we're kind of doing the opposite of that, right? Square root of 4 times square root of 2 is square root of 8, but then just taking that first number and actually finding the square root. Now, I can make this more difficult because it doesn't have to be a square root. It could be a cube root. So then you need a perfect cube factor, which most of us do not have memorized as well. So there's another way of doing all of this. You could do this with the perfect squares as well. You can factor tree it, which is 9 times 6, which turns into 3, 3, 2, and 3, which is 3 times 3 times 3 times 2. Now, a perfect cube means when you multiply a number 3 times. And as you can see, there's 3 3's there. So that's your perfect cubed. 3 times 3 is 27, which is a perfect cube. But since I circled that, since they're all 3's, your answer just has that 3 on the outside. That leftover 2 goes on the inside, and it has to stay a cube root. So if it was a 4th root, your answer should have a 4th root. If there's a 5th root, your answer would have a 5th root. that little number outside the radical never changes. It's always there. So if I would have said like the 7th root of some number, you could have factor treated it and looked for what number appeared 7 times. And that would have been your outside number, and then the leftover is your inside number. You could also reduce radicals with fractions. So I don't know what the square root of 8 is. I don't know, well, I do know the square root of 2 is about 1.414, but that doesn't really help. However, when there's 2 separate radicals, you can just make it one big radical. Why is that helpful? Well, we know what 8 divided by 2 is. It's 4. So you get the square root of 4, which just turns into 2. So when there's separate radicals, and if you can look at those and be like, hey, if I divide those, it's going to turn into a nice easy number, do it. You can also do this the opposite way. Square root of 25 over 9, turn it into 2 separate ones because we know the square root of 25 is 5 and the square root of 9 is 3. So then it just turns into 5 over 3. When we are adding radicals, they have to be the same number under the square root sign or the cube root sign or the 4th root sign. So to basically do this, we need to simplify both of them and hope that that radical is the same. And then we're going to combine them. If those radicals, even after you reduce them, aren't the same, then you can't do anything and you're done. 4 times 2 is 8, 9 times 2 is 18, and so square root of 4 is 2, so it's going to turn into 2 root 2, and square root of 9 is 3, it's going to turn into 3 root 2. And now if you look at those square roots, they're the same number, they're both root 2, so if I have 2 square roots of 2 plus 3 more square roots of 2, I now have 5 square roots of 2, which is your answer, and the radical stays the same. Lastly, this is the most difficult kind of question that you'll get. It's combining basically all of those radical rules into one question. So you're going to want to do these one at a time. Just concentrate on one parenthesis, then the next parenthesis, then the next parenthesis. Then see if you can combine anything, and then combine again. So I've underlined perspective change. I underlined that first parenthesis. So it says 4, and on the outside is the second power, so 4 squared is 16. And then if you remember, when there's parentheses, power to a power, you multiply. So 3 times 2 is 6, so x to the 6th. Negative 2 times 2 is negative 4, so y to the negative 4th. And then z, that's an invisible 1, so 1 times 2 is 2. Then we're going to do the next one. X to the squared to the 4th, 2 times 4 is 8, so x to the 8th. 3 times 4 is 12, so y to the 12th. Z, the resolution on this is not as great. I mean, my handwriting is bad, but it makes it a little bit harder to see. But anyway, negative 4 times 4 is negative 16. Then we got to do that bottom one. 2 to the 3rd power is 8, because 2 times 2 is 4, times 2 is 8. Negative 1 times 3 is negative 3. 1 times 3 is 3. And then 2 times 3 is 6. Now, since there's all that stuff on the top, we want to combine that. So since that 16 is all there alone and there's no other coefficient on that second term, it just stays a 16. I got x to the 14th because 6 plus 8 is 14. Because there's not the parentheses anymore, now we're just adding. Negative 4 plus 12 is 8, and 2 plus negative 16 ends up being negative 14. Now I'm going to put that one that's on the bottom there. Now we have to simplify that. So 16 over 8. If that was all by itself, 16 divided by 8 is 2. So it's going to turn into 2. 14. Okay. Some reason my microphone just died. Shouldn't have. It's been plugged in all day. But anyway, who knows where that stopped. But 16 divided by 2 is 8. 16 divided by 8 is 2. 14 minus negative 3. And it looks like a 5. I apologize, but that's a 3. So 2 negatives make a positive, so that turns into 14 plus 3, which is 17. 8 minus 3 is 5. That's why it's y to the 5th. And then z to the negative 14. Negative 14 minus 6 is negative 20. And since it's a negative, it goes to the bottom. Usually what I do is whenever the bottom number is bigger than the top number, and a positive is always bigger than negative, I subtract upside down. So 6 minus negative 14 is 20, and since I subtracted upside down, your answer starts upside down on the bottom. And yeah, pretty sure that was the last thing. Cool, cool, cool. About to do my next set of notes. Fun. Yeah, and just in case anybody, this is my new office that I just made just because I didn't know if we were going to do stuff online. Not too much to see. This is where I've been doing notes. So my camera's on that tripod while I was doing things. I have an owl up there that I got from AFN last year. Someone just texted me. This is my computer setup. Dual monitors. It's my computer over there. You can't really see the LEDs. And it was really boring, so all I had in here, because this used to be a spare bedroom, was that owl picture, which is really far away. So I brought my Star Wars Legos up here just to, I don't know, make it a little bit less boring. Anyway, time to do the next set of notes.